In this video, the learning target I'm going to talk about is I can solve quadratics in vertex form. So when you solve a quadratic in vertex form, you're going to get whatever stuff is being squared alone. Okay, that's kind of the first step. Take whatever's being squared in the equation and get that alone. And once you get that alone, you're going to take the square root of both sides of the equation. So if I look at number 1 here, I have 2 times the quantity x minus 1 squared plus 9 equals 63. And I notice that the parentheses x minus 1 is being squared. So I need to get that part of the equation alone. So to do that, I need to get rid of the 9 and I need to get rid of the 2. Okay, I just want the square on the left side of the equation. So to get rid of the 9, I'm going to minus 9 from both sides. That gives me 2 times the quantity x minus 1 squared equals 54. And then I'm going to divide by 2, which gives me x minus 1 squared equals 27. I can get rid of the square by taking the square root of both sides. Squares and square roots will cancel. I'll be left with x minus 1 equals plus or minus the square root of 27. I can then add 1 to both sides, and I get x equals plus or minus the square root of 27 plus 1. And then I just need to simplify the square root. So I have to think about what perfect square goes into 27. Well, it's 9, so I can rewrite this as x equals plus or minus the square root of 9 times the square root of 3 plus 1, because 9 times 3 is 27. The square root of 9 is 3, so I get x equals plus or minus 3 root 3 plus 1. Remember, you can't combine these because they're not like terms. You just leave your answer as that. All right, let's look at a second example. So looking at number 2, we got 3 times the quantity x plus 4 squared minus 5 equals 10. Once again, I want to get the part that's being squared by itself. So I want to get rid of the negative 5, and I want to get rid of the 3. So to do this, I'm going to add 5 to both sides. That gives me 3 times the quantity x plus 4 squared equals 15. I can then divide both sides by 3. I'll get x plus 4 squared equals 5. And then I can take the square root of both sides to get rid of the square. So I get x plus 4 equals plus or minus the square root of 5. And then I just minus 4 from both sides. So I get x equals plus or minus the square root of 5 minus 4. All right, I'm going to do 2 more examples here, kind of some different looking ones. We're going to look at number 3. Actually, we're not going to look at number 3, I'm sorry. We're just going to look at number 4. So if I look at number 4, I got x squared plus 1 divided by 3 equals negative 5. This v should not be there. That is a typo, so my apologies. So it should be x squared plus 1 divided by 3 equals negative 5, and I want to solve this guy. So once again, I want to get this x squared by itself. So I'm going to times both sides by 3 to get rid of the bottom part of the fraction. That leaves me with x squared plus 1 equals negative 5 times 3, which is negative 15. I then can minus 1 from both sides, which gives me x squared equals negative 16. And then I'm going to get rid of the square by taking the square root of both sides. So I get x equals plus or minus the square root of negative 16. Now remember, anytime you have a negative square root, that really means we're going to get an imaginary answer. So I can rewrite this guy as plus or minus the square root of 16 times the square root of negative 1, because negative 1 times 16 is negative 16. The square root of 16 is 4, so I get plus or minus 4. And then remember, the square root of negative 1 is the imaginary unit I, so we write I in place of that. Okay, so I equals the square root of negative 1. Okay, so we just rewrite that as I, and then that is our answer. Okay, so your answer should be plus or minus 4i. We are going to, like I said, skip number 3 because that has rationalizing the denominator, and we're not going to worry about that for now.